Hello, everyone, and thank you for joining us on today's Sensafili Sparring Partners webinar, How to Use Crowdsourcing for Network Planning. Our speakers today are Régis Lerbour, VP of Product and R&D at RAN Engineering at Infovista, and Monica Paolini, Principal at Sensafili. I'm Kendra Chamberlain, and I will be moderating the webinar today. In Sparring Partners webinars, we watch our speakers debate a topic live on video. We would encourage our audience to participate in the conversation. Please use the Q&A button at the bottom of the Zoom screen to share your comments and questions. All comments are visible to all participants, so please keep the conversation polite and respectful. Our speakers will do their best to address questions as they go along and as they become relevant to the topics being discussed. So please do not wait and share your questions at the end. And finally, we would like to thank Infovista for sponsoring our webinar today. With that, I'll hand it over to Monica.
Kendra, thanks so much for the introduction, and it's a pleasure to be here today to talk about crowdsourcing and network planning. And this is interesting, and this are two words that don't usually are together, or you will see more the two concepts together. But it's a new way to think about network planning, and so it's quite exciting to talk about it. And as many you probably know, I've been very interested in the planning part of network deployment, and this is because 5G or any other technology, they're great, but if you don't plan properly, the risk is that you spend a lot of money unnecessarily. And what crowdsourcing is doing is to help us understand the need, the need for coverage and capacity in a new way, which is not to remove the need to do the traditional planning. It's an addition. And we're going to talk about this today and how to do this in a way that you use data that it's more granular. And the question is, well, why can't we do it today? Why couldn't we do it like 5 years ago? And so today I have the pleasure to have Régis here to talk with me. So Régis, thanks for being with us today.
Thanks, Monica. I'm very happy to have that conversation with you today. Sounds very exciting.
Excellent. So give us a little bit of background on what is that you personally and Infovista is doing in this.
So at Infovista, what we do is offer solutions for our customers to automate the entire network lifecycle. And in my particular role as VP Product and R&D in the RAN Engineering department is to work on network planning, troubleshooting, optimization solutions to make that a reality for our customers. So personally, I've been working for many years at Infovista now, spent a lot of time with our network planning product Planet, working on defining the coverage analysis, the capacity analysis, the optimization solutions. And crowdsourcing is not an entirely new topic. It's actually something that came across 5 to 10 years ago when we started seeing crowdsourcing data being produced. And at that time, we evaluated the opportunity of leveraging that data in network planning, but the volume was not quite there. The providers were claiming billions of measurements, but then when you looked at the details and you wanted to see how many measurements you have every hour in a given neighborhood for a given operator on a given band, you ended up with very few points, which made it not representative enough for network planning. So that has changed. That has evolved quite a bit, and that's why network planning can now leverage crowdsourcing data to improve its accuracy and the automation of its workflows.
Yeah, and I remember, as I say, a few years ago, there was like this. Clearly, there is conceptually attractive to use crowdsourcing data, but the question is, can you use it reliably? And I think that's something that we should talk today, because as you use new source of data, you want to make sure it's reliable. So clearly we need to okay. Now before we get into this, maybe you can talk about what is crowdsourcing data.
That's
So that we know what we're talking. I think we know what network planning is, but what
I think
about crowdsourcing data?
this is a very good way to start the discussion indeed. So crowdsourcing data, generally speaking, not in the context of network planning or not even in the context of radio networks, is really about gathering content from a large crowd, from a lot of people, typically people that are online, so connected people, and typically without, well, sometimes people are aware of collecting the data, sometimes they're not. Now, in the context of radio networks and network measurements, there are multiple ways of collecting measurements. Can be active measurements, where the participant is artificially creating traffic in the network, which has some consequences. And there are passive measurements that is really simply about measuring data that is generated by the crowdsourcing participant. So in the case of network planning, and because we're really in the context of automation, we're really talking about passive data collection that is collected in the background and typically without the user of a mobile device even being aware that data is collecting on the device. So that's the kind of data that we call crowdsourcing data in the context of network planning.
Yeah. So basically, it's real data from. I mean, what I mean real is like it's not artificially created, because if you, as you say, the moment you create data, you create traffic. So it's not necessarily reflecting the usage. And I think that what's great about using crowdsourcing data is that you're just capturing live network situation, usage, demand, and what people are doing rather than what they could be doing.
Yeah, that's one of the great benefits of crowdsourced data. It's really live data that you collect automatically, that is rather cheap to collect compared to other live data sources. And that is an actual representation of the traffic that flows through the network. So it's not the full traffic, it's a sample of the traffic flow, but it's real.
Yeah, absolutely. So, as I said, conceptually, it's clear why you want to add it, but can you tell us a little bit more specifically about what is in network planning that made you think, well, this is the way to go?
So network planning traditionally, I guess 10 years ago and before, was all about complex algorithms that can predict how the signal propagates in the environment, and all about algorithms that derive from that to estimate coverage, to estimate capacity. So it was all about algorithms and predictions. In the past 10 years, network planning has evolved significantly to incorporate live data from the network, basically to improve its accuracy, because algorithms are great, but algorithms have a limit in terms of accuracy, and all environments happen to be different for so many reasons. So that's evolved a lot, and many data sources have been incorporated in the network planning processes over the past 10 years. You have, of course, drive test measurements, you have call traces, you have performance management data, you have feeds from social media, et cetera, but none of those data sources is the holy grail. So the trick in network planning is really to take the greatness of each individual data source and to combine them together appropriately in order to build something that is an accurate view of the RF environment. And crowdsourcing is one of those components. I would say it's one of those components that ticks many boxes, but not all of them. We'll talk about that. But combined with other live data sources, we end up with something that is really solid in terms of representing the reality of the network.
Yeah, absolutely. Now, you mentioned accuracy in network planning. What does accuracy mean? I mean, we all have sort of an intuitive understanding, but I think you were talking about something specific about, because you can say, well, I know that I need more capacity in this location, but that's not, how can you, what does accuracy mean in this context?
So accuracy in the context of network planning, it's very simple. It means CapEx, because If you're too optimistic in your estimations, well, you're just going to end up with coverage holes or capacity shortage that will mean unhappy customers and churn eventually. If you're too pessimistic in your network planning activities, you'll end up with another dimension network that will cost a lot of money for no benefit for your end customers. So accuracy is really about finding the right trade-off so that you spend the right amount of money building the network for the right return on investment.
Yeah, or at least you know exactly where to put your money. So if you have whatever budget you have, you put it in the right place. Because traditionally, when you talk about to operators in terms of how do you decide where do you put the next you need to put a new base station. Where do you put it? And the answer you pretty much get is like basically you over engineer the network, because that's the way that you can cover your bases so your customers are happy. But as you say, yeah, you can do that, but it's just going to be more expensive, right?
And that's very valid for greenfield network deployments where you start from scratch. You need to cover the population. You have regulators chasing you to achieve certain KPIs. But the majority of operators nowadays, they don't start from scratch. They have an existing network that is made of multiple layers, at least 2 layers, 2G, 3G, or 4G. And they go and deploy 5G, or they go and deploy new technologies like massive MIMO. And in that context, they have a certain budget that they're willing to spend on a certain time period, let's say the next 6 months, the next fiscal year. And what they need to know from the network planning is, where do I spend this money to get the best return on investment? Where do I deploy massive MIMO antennas to capture more revenue from the network? Where do I deploy 5G as a priority to capture the capacity that 4G is not able to capture today? So that's really about confronting the QE, the quality of the network, with the reality of where the end customers consume the network. And that's where crowdsourcing plays a great role, because that's what it achieves. It achieves giving visibility as to where your end customers or mobile customers in general do consume the network, to identify these hotspots of traffic where you want to deploy new technologies.
Yeah, well, and actually you capture more than just usage, you capture demand as well, especially if you're a new operator, because you're not confined with crowdsourcing data to data on your own network.
That's one of the great benefits about crowdsourcing data. If I compare that to the other data sources that I talked about earlier, like layer 3 call traces, for instance, which is great. It's exhaustive. It has all the calls in the network, but it is only your network. So if you're a new operator, obviously you have no network, you have no infrastructure to collect the call traces, so you don't have any visibility. You're completely blind. With crowdsourcing information, you have the visibility about, well, your competitors or your future competitors, to understand where their customers consume the network, and that really helps in prioritizing the network rollouts.
But even if you are an existing network and you have a very well-established subscriber base, let's say you have an area where you don't have very good coverage, really bad, but you might not necessarily, you might know that, but you don't know what the demand would be there if you had a better coverage. So it's still helpful to know what is the demand that you cannot satisfy. Just because you don't have enough traffic doesn't mean that you couldn't have it if you have a better network there.
And that's a very good point. It's a way to identify what we call the unserved revenue from the network, which starts from the unserved traffic demand that today is not captured. And that's a way you can confront yourself to your competitors. If you see that they're serving demand in an area, but you're not, it really means that you have a coverage problem to fix.
Yeah, absolutely. And I guess so what that tells you, that is the crowdsourcing data versus the existing network data. When you put it together, it's interesting to see if there is any discrepancy there. Is it something that we haven't looked at? Okay, so now that is all very good, but let's just talk about sort of the challenges, because another reason why I would imagine that crowdsourcing was in use. It's like, okay, so one thing is that, do you have enough data that is reliable, but then how do you integrated with what you're doing, because obviously you're adding a lot more work, more data, and you need to do this. So let's talk a little bit about how does it work from the crowdsourcing data onto the network. So maybe we can start talking about, can we trust this crowdsourcing data?
So it takes a few steps, and talking to many customers and many people in this industry, people have doubts about the benefits of using crowdsourcing data in the context of network planning, because I think people understand what crowdsourcing data is, and the kind of limitation that it comes with. So let's talk about these limitations, and then we can talk about how we'll overcome those to make the data really usable and really powerful in this context. So limitations first is, well, the data comes from a diversity of devices. It's collecting from any device in the network. Those devices collect measurements in different ways, in different chipsets, etc., etc. There are different OSs running on the mobile devices. So the validity itself of the data can be a problem. The reliability of the data collection can be a concern as well. And I would say here that just the fact that you collect so much events with a crowdsourcing solution, that just the volume of the data helps to average out these kind of problems. Of course, after you've done all the cleansing of the data to remove the outliers, etc., the volume of the data means that you can get something that is quite reliable. I guess the biggest concern that people have is how representative the data is. And for that, we need to understand how the data is collected, and what is the trigger for data collection. So it's collected from typically an agent running on the phone, and the agent is embedded in mobile apps, typically apps that have that kind of business model. So that would be gaming apps most of the time, or different type of apps that live this way with ads and with these kind of partnerships. So that's one thing. You need to understand what type of apps are collecting this data, because that kind of impacts the population that is using these apps, and hence the type of population that is creating those measurements. The second thing is what is the trigger to collect the measurements. In many cases, to get the accuracy, we want the measurements to come with GPS coordinates. So GPS coordinates are not always, well, GPS is not always on the mobile devices. It's different from mobile to mobile. And some apps, well, typically the driving apps tend to have the GPS on more than others, which means that you can get a lot more measurements outdoors than indoors, simply because you have a lot of driving apps that are collecting the data with the GPS being on at the same time. So those are the facts of the crowdsourcing data. But once you understood the fact, and we spend a lot of time with our partner Umlaut to understand the facts, then you can post-process the data to remove those biases and make sure that the maps that you're providing eventually in the network planning context have eliminated those biases.
Yeah. So so you don't just take the raw data and plug it in. Well, I guess so. You need to sort of make sure you understand and go through the data. Now you mentioned GPS. What does it do in terms of being able to collect data from indoor traffic?
So this is another concern, one that does not apply only to crowdsourcing data. By the way, that's something that applies as well to the kind of MDT data that's collected as well from GPS coordinates. GPS is not that great indoors. We all know that. We've all experienced these kind of issues with our own phones. So that's a challenge, and that's one of the problems that also we can fix by post-processing the data, because we know that indoor is not great. So we have ways to reverse engineer this kind of behavior, to put the data that should be indoors, and to keep the data that's rightfully outdoors.
Yeah, yeah. Now I have to ask you this, in terms of privacy. Some people say, "Oh, you're tracking what it is that I'm doing." You know, what's the answer to that?
So I would that first of all, the privacy. I'm no legal expert. That's
Yeah, we're
complex.
not giving any legal advice. It's just
No.
technology,
I wouldn't do that.
technology talk here.
I will not do that. But it's very complex. It changes from country to country. You have strict regulations in the European Union. You have almost no regulation in some countries. So that's a complex environment. At our level, the only thing I can say is once the data is collected, it's completely anonymized. In network planning, we have no visibility whatsoever on who's using the device, on not even the IMSI or any kind of information like that. The only thing we have at the network planning level is RF metrics. So RSMP, RSSI, CNR, throughput, etc., band, cell IDs, operators, just RF metrics. So there's absolutely no concern to have about privacy. It's really about using the data to improve the network.
Yeah. Final question on the crowdsourcing data, and then we can move on. Is there any bias in terms of different devices? So, for instance, is like iPhone, Android, different brands or something like that?
Yes, there are differences there because there are different ways of collecting the data. It's again between active and passive measurements. Passive measurements are much easier to collect on Android devices because the Android SDK allows to collect that information. So there are differences, and we see, for instance, in the amount of volume that you get from country to country, that differs depending on the adoption of iPhone devices in those countries. So we have differences there, but then that doesn't impact too much the accuracy of the data itself. It really impacts the volume of data that you can get in different countries.
Perfect. So we have a question for the audience, and for all of you in the audience, if you have any questions or even comments, post them in the Q&A now or before we go, because we're not going to have a Q&A at the end. We just take questions as we go. And the first one actually fits very well with our discussion, and that's from William Flores. And it's how artificial intelligence and machine learning are used to collect collected data from users.
So that's an excellent question. I think there are multiple answers to this question. The first one would be about the data collection itself. I will not expand too much on that one because we're not collecting the data ourselves. We're working with a partner, Umlaut, who's collecting the data. So I will ask them how much artificial intelligence is involved in the process. I suspect there is because that kind of post-processing needs to rely on artificial intelligence to be reliable, to be automated, and to improve over time. The second aspect around this question is how the data itself can benefit to artificial intelligence algorithms. And that's an area that we've researched extensively. We've released a brand new propagation model in Planet a few months ago that is entirely based on artificial intelligence. Model is called AIM, Artificial Intelligence Model. And the fact that that model is based on artificial intelligence means that the model improves its accuracy over time. The model keeps learning. So when you combine the power of a propagation prediction model that is based on artificial intelligence with the volume of network data that you get from crowdsourcing, then while you have the perfect combination of artificial intelligence and data, because AI is nothing without data. So really, we are working on that. We've made significant progress, but we're quite convinced that these two things put together can really change the future of network planning.
Absolutely, and you know, it's sort of like a continuous learning, and not just AI. I mean, everything really. But you know, this is certainly there. So it's going to be more and more interesting to see how that works. Now, the other thing that I would add here, ask you about is automation, because it's all good to have AI and machine learning, but that clearly you have much more work to do, and that's where just doing it manually with, I've seen, you know, for some of the planning, like, you know, the Excel spreadsheet that just doesn't
Well,
I mean,
Excel.
I've seen like in some contexts, the Excel spreadsheet. Excel is a great
Well,
thing, but not for
we've
this.
we've seen that ourselves because before investing in that direction, we had support for crowdsourcing data in Planet, but that was more of a manual process whereby you would import the data from a spreadsheet or a CSV file, and then you will process it manually, post-process it, and ingest it in the planning algorithms. And clearly that type of work is fine for small area if you're considering a small period of time, because we'll have a number of samples that's reasonable. But truly, as soon as you want to cover a larger area, even a market or even a country, and if you want to consider a time period that goes beyond a few hours, that's just impossible. I mean, even Excel will blow up to start with. You'll have to use CSV file, and then you'll have CSV files that are gigabytes and gigabytes of data that are not being processed in a timely manner. So that's why we moved in a completely different direction, whereby the data is pre-processed, pre-aggregated, so that once you connect in Planet to the database of crowdsourcing information, it's very fast. You indicate the area you're interested in, you indicate the time period you're interested in, maybe some filters. I'm interested in my own network or the network of my competitors. I'm interested in 4G or 5G and such bands, etc. And then you get only the data that is relevant and only pre-aggregated data. So it's not billions of measurements, it's pre-aggregated, so it's really ready to be consumed by the network planning workflow.
Yeah, we have more questions for the audience, but I want to follow up on the what you're talking about, because so we used to think that you need to get a new network or expand your network. You do the planning, you're done, you go, and this is changes in a way, because it's more of a continuous type of activity, because you keep getting crowdsourcing data, you keep looking. So it's planning, but it's also sort of monitoring the need to expand your network, right? So again, you just, the reason why you need automation and AI is because you can continue going through the process. It's not just a one-off effort.
Absolutely, and people that are not deep inside network planning often think that network planning is one of the first steps in the network lifecycle, and then you do it, and then you move to the next step. The reality is that you always do network planning. It's never finished. You do the first rollout, of course, but as soon as you've done that, then you have to optimize the network, you have to expand, you have to increase capacity. So you keep doing network planning. And the fact that we now have artificial intelligence and these kind of data sources that keep coming in and keep improving the accuracy of what you're doing, it's really helpful in that context.
Okay, so we have a bunch of questions. So the first, hold on, I'm sort of trying to, okay, there is one here. Will the crowdsourcing be able to completely replace drive tests?
Oh, that's a good question. The short answer is no, because drive tests will always be relevant in some context. For example, you're launching a new network, you want to test your network, you want to benchmark it to the competitors, but the network is not live yet. So you need to do drive testing to achieve that. Other use cases, there are plenty of use cases for drive testing. Some of them can be partially replaced by crowdsourced information, by a combination probably of crowdsourced information, geolocated call traces, MDT data. But some use cases, I think, will be very difficult to replace, and drive testing will always play a role.
Yeah, okay, good. So we're still, and I guess the way to think about it is that crowdsourcing adds to network planning. It's not a substitute, it's a complementary. It's just having a new tool in your toolkit rather than.
Absolutely. I mean, the same example, you're launching a new network in greenfield area. You need to deploy new cells. You have no information. You need to rely on those complex algorithms that I was talking about. That we're improving thanks to crowdsourcing and artificial intelligence. But you need that. You cannot rely on just the data, because in some contexts the data doesn't exist. And even in an existing network, you'll have data about the live cells, but you have no data about the new cells that you want to deploy, the network expansion, the densification, the massive MIMO addition, the 5G deployments. You have no information about those cells because they don't exist. And that's really what network planning is about at the end.
Yeah, absolutely. And let's move to the next question from the audience. It's okay, so apart from the data collected from the user equipment or handsets, what other sources of dynamic data is used and fused in Planet?
Apart from data collected from handsets, so we have a lot of data that can be collected from handsets, crowdsourcing, layer 3 call traces, MGT, drive tests, of course. Other sources of information can involve geographical information that can be used in Planet, and that's typically the first thing you do because you have the geographical information to do your planning anyways. We have information from social media feeds as well that is rather dynamic, keeps coming. The volume is not as good, but it's quite helpful in some use cases. So we really have a diversity of data sources, and they all have their pros and cons, and all can be used in certain contexts for certain use cases, which means that whichever situation you're in, you'll find the data source that's applicable.
Okay, we have two more questions that I'm going to combine into one because I think that they're related. And so the first one is the amount of data that you get from crowdsourcing is going to be reliable for doing RF optimization. And I would like to ask here, you probably have, like in different markets, in different areas, you might have more or less. So I guess that the weight that the crowdsourcing data might have in those circumstances might be different. And then you need to sort of accommodate for that. And then the second one, it's what are the criteria for high quality crowdsourcing data in order to be used? Which I guess, again, if you know that you might have the data that is just not as good, you might give it a little bit less weight. So how do you go about it? Because it's not probably a black and white situation either, right?
Absolutely. And I think that to answer the first part of the question, that relates to what I was saying earlier about the situation 5-10 years ago about crowdsourcing, where if you go down to the neighborhood and the band level, you didn't have that many measurements, so it was not possible to use. Now with the expansion of data collection in mobile apps, we have a lot more measurements. So you have hundreds of measurements, even for small periods of time in a given area, which makes it really reliable for this kind of workflows. Now, I forgot the second part of the question, sorry.
It was about, hold on here, is how do you make sure that the quality is good enough?
Yeah, so I think you need basically to look at your environment, look at the area that you're interested in, and see the amount of measurements you get and the spread in the RF metrics that you collect from those measurements. If you see a very large spread, that really means that the data is not statistically representative. There are few areas like that, but it can happen. And if the spread is much smaller, that really means that your data, well, it makes sense, it's consistent, and it's really applicable to network planning.
Yeah, okay, so we have more questions from the audience. Let me try to get to them. Okay, do you localize the tower coordinates from the crowdsourcing data, and how will this tower accuracy affect possible future coverage predictions? So basically, how do you map crowdsourcing data to your existing network if you have one?
So in Planet, you configure your network. You can do that from CM exports from the OSS. So that's quite accurate. That information does not come from the crowdsourcing data itself. What you have in the crowdsourcing information is basically cell ID that we use to map the measurements to the cells in the digital twin of the network that we have in Planet.
Yeah. Okay. Good. Now, this is actually a question that I never thought about it. So, how do you get crowdsourcing data from IoT devices? They don't play games. They don't drive around.
No, I don't think IoT devices will be using these apps. So in theory, nothing prevents an IoT device to embed the kind of agents that collects the data. I haven't thought about that either, but I think one challenge would be the battery life on their IoT devices. One main constraint with IoT devices, especially the unattended devices, is that they should not transmit too much information to save the battery. And that does not quite align with the principle of collecting crowdsourced data.
Well, and I guess that, I mean, the issue is that if you have like sensors, they don't really add much to the capacity requirements. So it's kind of a rounding error in a way. So you don't really need to know that. I mean,
Yes,
I guess
and
coverage is an issue, but then you just, whoever is the IoT customer will tell you.
Yeah, and then they are typically static as well. Crowdsourcing information is quite relevant to give a view of the mobility as well, which is less of a factor for IoT, of course.
Okay, this is, I think it's a little bit more of a technical question, but probably can answer pretty quickly. So can crowdsourcing data be collected when the UE is in idle mode or out of coverage? Well, obviously, if it's out of coverage, that's not, it's difficult. But is MTD has logged MTD mode for such purposes when data like geolocation is reported back later in time once UE enters connected state. So I guess basically it's like, can you get the history when you was on?
Yeah, well, you can. We don't do that in network planning because it's not network troubleshooting. So we don't follow individual subscriber of the network. But in different use cases, and troubleshooting optimization can be one of those use cases, you could use crowdsourcing data for that purpose. But in network planning, it's really the volume of information that matters. We don't really care whether that's user A or user B that is consuming the network traffic.
Okay, we have another one, which is about how crowdsourcing data can manage different elevation points into a building.
So that's about I guess 3D geolocation of the devices. So we discussed before about the accuracy of GPS coordinates indoors not being great in 2D. I would say it's even worse in 3D. So we don't rely on that information because it's not that reliable. However, as I said before, in Planet we do post-processing and we have algorithms that are able to take other factors into account, like geolocated call traces, where the 3D accuracy is better, like social media feeds with 3D accuracy as well, with geographical information where we know the height of every single building. So we have other ways to take the information of a particular building and make sure that we spread it appropriately at different floors of the building. And that's quite important if you think about it. If you think about the use case, like I want to deploy massive MIMO antennas. Well, massive MIMO antennas, especially if you're doing 3D beamforming, it's very important to know how much traffic demand you have, not only at the ground floor, but also at the floors in the middle and at the floors at the top. That will completely change how you design your massive MIMO system.
Yeah, okay, we have another question. Feels like a question from all directions. So this is Simon Sanders. Hi, Simon. Okay, so is having data collection agents embedded in an increasing number of games and utility apps really ethical and responsible? I'm not convinced that users are really giving informed consent.
That's really on the privacy aspect. I would agree with that. I think people just tick the box when they first load the app without realizing that they're sharing that kind of information. That's the reality of our world, I'm afraid.
Yeah. Well, and I guess that this is a sort of a broader issue of data ownership. Who owns the data, how you control it, which it's a major issue, and I think that we need to
Yeah. To be honest, I would be I mean, from a personal point of view, I would be less concerned by this kind of data because, again, it's really RF data. There's no personal information whatsoever in the data that we collect and that we use. I'm less concerned by that kind of data sharing than personal information sharing.
I guess that, when you check the box, you don't know what you're checking, and if you tell people, we're using it for now, if those people will be on this webinar, understand what you're using the technology, the information, probably they wouldn't care. The problem is that they don't have that information because of the constraints of the, and the way things are regulated. So,
no, that's a fair point. Yeah.
Yeah. Okay. Good. We have more question. Well, there is a question. I'm not sure I understand. It's like they are crowdsourcing data is generated by the user, but there are others that run in the second plane. What is more reliable? I'm not sure what the second plane is.
I'm not sure either.
Okay.
Maybe that's referring to layer 3 call traces that is collected by the network itself, which is in a way crowdsourcing information and reliable crowdsourcing information because it's completely exhaustive. It has every single call in the network. That is very reliable. The challenge with that is it doesn't come with GPS coordinates unless MDT is enabled. But yes, MDT is as reliable as crowdsourcing information. It is just less popular, I would say, these days. People are talking about it, but still it's not enabled in many networks.
Yeah, and I guess that the GPS, the reason why it's important is because you understand where within the cell you have the user. So it's like a cell edge or where with respect to the cell.
It's good that you mentioned it because we haven't even mentioned it, but that's the key thing with crowdsourcing information. If you compare that to performance management KPIs, for instance, that are really at the cell level, what crowdsourcing brings is moving information that is from the cell level to the pixel level, so that you really understand in which areas of the cell the traffic is coming from, or in multiple areas of the cell. But a cell is not homogeneous. It's a lot of different hotspots.
So basically, let me just sort of like think it through here. So let's say that you have a cell where everybody is at the cell edge. So it looks like the performance is actually not very good, but it's not, doesn't mean that it's there's nothing wrong. It's just that people are on the cell edge. On the other hand, if you have the same cell, but everybody is close, not in the cell edge, it looks like the cell is performing much better.
Yeah.
So,
there
basically yeah, but I mean, I'm sort of simplifying here, but I guess that's the issue, that just by having the data from the handsets related to the cell, you might get somewhat very different results depending on where users are.
Yeah, of course. I mean, if you try to do network planning purely based on cell level traffic volumes, then you're missing the entire point about network planning. So that does not work. You need to distribute that traffic within the cell area. There are ways to do that in a very statistical way, but bringing live information from the network, live geolocated information from the network into that process increases the accuracy tremendously.
Yeah, and also if let's say that that everybody is sort of like at the edge, at the cell edge, and that's because there is something there and you don't have very good coverage, you might know that you might want to put a small cell right at the edge. Yeah. So that again, you can get more value for your investment.
That's, I mean, we've talked about traffic density modeling, which crowdsourcing contributes to, but then traffic density modeling contributes to so many use cases within network planning and optimization that can be about deploying network, yes, that can be about optimizing a small cluster, as you said, problems at the cell edge. Do I need to deploy a new small cell? Do I need to reconfigure the surrounding cells to reduce interference or to basically up-tilt the antenna so that covering the cell edge better? There are multiple ways of doing that, and without geolocated information about the traffic density, you cannot get it right.
Yeah. Now I see another question that I'm not sure. So it's having all the RF related crowdsources data coming from Android devices create any challenge in the analysis? Now it's not just Android.
It's majority coming from Android, because Android facilitates that collection.
Oh, okay.
I would not say that it creates a challenge in the analysis. It's really only a challenge in terms of data volume because you don't have that much information from the other devices. But then the majority of the devices are Android devices in most geographies.
Yeah. Now there is another question that came through the chat, so we shouldn't really, but we're gonna take it anyway. And this is how do you determine cell radius how can you use, how can you determine cell radius to decide how many UEs a new cell can service? And I think that this is kind of beyond crowdsourcing. It's nothing, I mean, that's kind of a next step.
The network planning question, which I'm happy to answer because it's always fun to talk about network planning. It's based on algorithms. Typically, you have propagation algorithms. If those are new cells, you have no other way than to rely on propagation algorithms that are going to look at your geographical environment to estimate the path loss between antennas, and you'll find where your cell edge is. Of course, it's statistical. It's not a black and white answer. So it's all a question of coverage probabilities at the cell edge.
Yeah. Now, you know, we talked about how planning is kind of becomes more of an ongoing process with crowdsourcing, because with crowdsourcing you have near real time. I mean, dynamically updated data. Now you can use it for planning, but you can also use it for optimization, right?
Yeah.
So how is that working?
So that's another set of use cases beyond network planning. Of course, once you've deployed your network, the crowdsourced data remains valuable. So in the context of troubleshooting, to start with, it's always relevant to, well, compare yourself to your competitors. As we discussed earlier, if you find yourself in an area where you're getting a lot of complaints through customer care, but you see through crowdsourcing information that you don't have data from your network, but you have data from the competitor's network, or that you do have data from your network, but that the KPIs look much worse than in other networks, then you know that there's something to do in terms of optimizing the network to fix this issue in this particular area. And then as you move to the network optimization, the crowdsourcing information is relevant to avoid, I would say, the back and forth between potential solutions. We have seen a lot of optimization engineers that complain about this problem, that one day they're going to uptilt the antenna to fix one problem, the next day they're going to downtilt the very same antenna to fix a different problem that was created by the initial optimization. So relying on crowdsourcing information means that you build an overall view of your network, and you can make sure that whatever optimization step you're taking to fix a problem is actually fixing a general problem, without creating a new one. It's producing the optimal configuration for this cluster.
Yeah. And I guess, that's a good point, because you never know what's going to happen, I guess. Well, I guess, and that's where maybe AI and machine learning will help, because you might be able to say, if I do this, what's going to happen? So you can predict.
Absolutely.
Instead of actually doing it, just simulate what's the impact of optimization.
Definitely. And there's as soon as you have data volume, AI can do great things.
Yeah. Now let's get a little bit kind of sort of more detail in terms of back to the network planning, but I guess it applies to optimization as well. As we move to 5G, massive MIMO, network slicing, it just seems like the network planning, or the way you deploy and operate the network, is going to be not only more complex, but so you need to look at more elements. Is crowdsourcing going to help you there?
But I think it helps because it goes in the direction of automating more and more all processes, including network planning processes. So anything that contributes to automation eventually helps dealing with the complexity of the networks. And 5G is, I mean, the best example of complexity, because while it's more complex than other technologies, but on top of that, it adds, it does not replace, it adds to the complexity of other technologies. So operators are looking for time, for the best engineers to spend on 5G. And for them to spend time on 5G, they need to free up time from 3G and 4G, and automation is required. And crowdsourcing contributes to automation, as we discussed, for many different use cases.
Yeah. So what about, for instance, for network slicing? So the question is that you're an operator, you have a network, you don't know whether you can support network slicing, and so how can So I guess my question is like, how can you use crowdsourcing data, and you know that it's coming from specific applications. Can it be used from the operator to understand, can we support network slicing services? And if not, how much we need to change the network?
So just like the other use cases that we talked, it's not going to directly tell you you can support that kind of slice for this customer with this kind of service expectations, but it's going to indirectly contribute to that to a great extent, because it will improve the accuracy of your network planning. It will improve the ability for the network planning processes to be run in the background in an automated manner, which means that once you have a new customer who's requesting a quote, say, I want a slice for my factory located in this area, and I want to have that kind of service with this kind of quality of service requirements, you can automatically, with the power of crowdsourcing and artificial intelligence, produce the results of what the network can deliver today. And if the network is not able to deliver that performance today, you can also go through simulations to say, this is how much it will cost me to support that customer requirement. So you can then build automatically an ROI analysis, so that the customer business is worth that much, and that's how much it's going to cost me to serve it with the required quality of service. So crowdsourcing contributes to all of that automation.
Yeah, absolutely. And it's a way to sort of to see what would happen, what if. So it's not just, again, if you have a new service, if you want to try something new, you can see how much is it going to cost you, and then you compare to how much you're going to, and you can do it with more reliability. Now, you sort of touched a little bit on this, but maybe you can talk a little bit more in terms of what are the advantages in terms of user experience, cost, reliability of the network. How do you see that changing?
So you mean what are the benefits of crowdsourcing versus other data sources that could be used in a context?
All right. Actually, more generally, because basically what you do is that you improve your planning precision, accuracy, as we talked before. How is that going to help you? I mean, they're just clearly like, the better, but what explicitly, what is the benefit for an operator? Because clearly it's more work for them, or, so is it
actually it's not. It's really the benefits of the integration we've worked on with Umlaut is that it's not more work. It's 3 clicks to leverage the data. It doesn't take time because everything is pre-aggregated. Everything has been pre-processed, pre-cleaned, etc., etc. So it's absolutely not more work. And the benefits, they are clear. They are eventually in terms of network planning accuracy, which means lower capex for the same user experience and better return on investments. Those are the best, I guess, benefits that any CTO within a mobile network operator will look for. And the beauty of what we've done is that it does not come with more complexity. Actually, quite the contrary. It comes with more simplicity for the network planning engineers.
Why is there more simplicity? So basically, they don't mean it's like almost a block to check.
It's a checkbox. I want to use crowdsourcing data, and then everything is done in the backend. It's all downloaded automatically on the fly.
So basically, they don't have to do the cleaning out the data on their end.
They don't have to do the cleaning, and more importantly, they don't have to manage the data flows themselves. They don't have to go to a platform, export data in whatever format, then go into the planning tool and import the data and make sure that the data is not too big and split it in multiple files if it's too big, etc., etc. They don't have to care about any of that.
Yeah. And I guess that's also part of the whole automation process. So they have the comfort of having all this data being used, but they don't have to actually.
Well, it just makes automation possible. If you think about all the steps you have to take to export the data, clean it, split it in multiple files depending on volume, etc., that creates automation workflows that are too complex to put in place with too many different scenarios that could happen. With what we have, well, it's already ready for automation.
Yeah, but I guess that when they do have to run simulations, then they would have, I mean, that would be, I guess it wouldn't be difficult, but I guess it's a different tool. That would be something that they have on top. So if they want to run a simulation, it's something new that they have in addition that they might or might not use depending on what they want to do.
Yeah, and the simulation in the context where simulations are the only solution because there's no data, you can still leverage crowdsourcing data to improve the accuracy of your simulation. Because again, we're talking about AI-based simulations that can learn from the crowdsource. So even if you don't actually have data for the band that you're deploying, even if you don't have data for the area in which you're deploying, you can still train your simulation models with that data to improve the accuracy in the new band, in the new area. So in all cases, it's beneficial. And it's a great way of, I guess, leveraging data that exists for improving the future simulations.
Yeah, which I guess has always been an issue because there's always more data that you can use. And now finally we got to a situation where you can actually use that data.
Exactly.
Learn from it.
I think it's been a frustration for a lot of people to be sitting on that much data without knowing what to do with it. So I think now we are starting to reach the stage where the data is becoming useful.
Yeah. So there is another question, which I guess somewhat related, and it's from David Barker, and the question is: will real-time crowdsourcing become a key enabler to deliver the benefits of real-time AI-driven self-optimizing networks? And I think that actually, maybe you can first talk about what is real-time in this context, because real-time means all sorts of things in different contexts. So. Yes. What is real time, and then we can talk about.
I agree with David who's asking the question. I think crowdsourcing is going to be a key enabler to this kind of workflows, basically closing the loop, the optimization loop in the network. But yes, I agree with you that we need to define what real time is. We're not talking about seconds here. We are talking about hours, maybe 1 day maximum, which to me is still real time when we talk about not optimizing parameters of a given cell or just basic sound scenarios, but actually cluster optimization, something that sound so far has not been able to deliver. Sound's been limited to very simple use cases. Cluster level optimization, I think, has a lot of value and will be enabled with network planning automation powered by crowdsourcing.
Yeah, well, but I guess also, here with real time, I guess that maybe the way to think about it is more like dynamic, that it constantly keeps updating. It's not real time in the sense of reacting to congestion or whatever, that you don't have that. But also you're going to be able to have, it's not only time, but space, but it's also time, because you know where people are at, for instance, at different times of the day. Mm-hmm. And that is really important, because you don't want to plan your network just based on, just on average.
That's a key point as well, and the beauty of this data, which means that when you decide to use this data, you can say, I'm interested in the data that comes during working hours or during peak hours or during morning, evenings, whatever you decide, and that allows to cover certain scenarios. We did a study last year, the COVID situation. We're still in that situation, but I guess it was a bit worse last year, where most of us were being locked down. And you could clearly see the move of network traffic demand from the business areas to the residential areas, where actually people were now working from home during the day. And that was very visible, the change before lockdown, after lockdown. We did that in many cities, and that was extremely visible. And operators were caught off guard when that happened. They got capacity issues in certain areas that they could not have predicted. So with this type of solutions, they can actually plan for this. Whether that's COVID, now we think maybe that will happen. We haven't thought that could happen, but now we think it can happen again. But other type of scenarios that we haven't seen today, but maybe operators need to plan for. With this information, they can do it, and they can adapt very quickly to a new situation.
And you can imagine a situation where you start seeing, like, progressively increasing adoption of like things like XR, it's different type of extended reality, and you need to sort of you need to keep tracking as it grows, and it's going to be more sort of a gradual. We're at the top of the hour. Just very quick question. How do you see what's next? How can you improve the way you use crowdsourcing data in both planning or optimization or everything else?
That's a good question, because the topic of proving which network planning is better than the others is always complex, because you only know the truth a few months or even a few years later, once the network is up and running and you can validate your original assumptions. But we're running some studies internally to validate that, showing different kind of simulations with the crowdsourcing information being leveraged versus without the crowdsourcing information being leveraged, and it's showing some good results so far. And we've done some other studies internally to see how crowdsourcing data can benefit AI-based simulations. And that's very promising as well. So we will have some more information to share very shortly.
Excellent. Well, that's great. Well, Régis, thanks so much for taking the time to talk to us today.
Thank you very much. It was a great conversation with you. Thank you, Monica.
And thank you all in the audience and for listening in, and back to Kendra.
Okay, great. Thank you, everyone, for that webinar. And thanks again to Infovista for sponsoring today's webinar. A recorded version of the discussion will be available at the senseofphilly.com website in the coming days. And we have another Sparring Partners next week, December 15th, and that will be on the future of spectrum policy. Registration for that will be available at senseofphilly.com. Thanks again, and we look forward to seeing you at future events.